Alright, so today we are working just on reviewing exponent rules. Positives, negatives, multiplying, dividing, powers to powers, different products to powers, quotients to powers, things like that. So I'm going to go through a few of these with you here. We are on page 700 in your textbook. We're looking at problems 20 through 43. This first one is problem number 20, and it's negative 6 raised to the negative 4 power. When you see a negative power, what do you think?
Fraction.
Fraction. Okay, yeah. How do you make a negative power become a positive power? Move it. If it's on top, move it to the bottom. If it's on the bottom, move it to the top. Okay, so when I see this, okay, I'm not going to type this into my calculator because it's probably going to give me some decimal. And yeah, I can probably change it to a fraction, but sometimes calculators don't change into fractions really nicely for you if the fractions are too large of numbers. Okay, so if I would see this problem, I would first write it as 1 over negative 6 to the 4th power. I would move it to the bottom side of the fraction first. Okay. Then I would probably see what negative 6 raised to the 4th power is actually equal to. So I'm going to take negative 6 in parentheses raised to the 4th, or negative 6 times negative 6 times negative 6 times negative 6. When I do that, will I get a positive or a negative number on the bottom?
Positive.
Positive, because a negative number times itself 4 times will give you a positive. And has anybody completed that yet?
Yeah.
What is it?
1296.
1296. Right. Okay, so that answer would be 1 over 1296. Okay? Any other thoughts on that one?
Okay. See guys?
Yeah, right. Okay. The next one, how is it different?
I just have parentheses.
There's no parentheses, so what does that mean?
Make it negative at the end.
You kind of save that for the end. What number is actually being raised to the negative 4 power?
6.
Just the 6, okay? So what I would write here is I would kind of throw that negative sign out in the front. Okay, that's this negative right here. And then I would write the fraction 1 over 6 to the 4th power. That's how I would write that one if I'm writing my next step here. Okay? Because this negative sign is not part of what's being raised to that negative 4 power. So I'll just keep that kind of out in front separate. I'll just do the 6 to the negative 4. 6 to the negative 4 is 1 over 6 to the 4th. We know from the previous problem that is 1296. So my final answer this time is a negative 1 over 1296. Okay? And I believe that was problem number 21 as well. So we hit 20 and 21 there. Biggest reason I wanted to show you both of those is to make sure you're aware of what number is actually being raised to the power. There is a difference when we have parentheses around that number versus when we do not. Okay? Very important. It's commonly missed. Okay? Next problem could be done a couple different ways. You guys have some ideas?
25 times 13.
Take 5 times the 3 right away.
Yep.
Okay? Take 5 times the 3 right away and then square it. Or what else could you do?
Square 5, square 3.
Square the 5 and square the 3
Multiply together.
and then multiply them together. 2 ways. Either will be fine. I'm going to show you the second way you mentioned. Take 5 to the 2nd power times 3 to the 2nd power. Okay? So then you have 25 times 9. And if I had 9 quarters, how much money would I have?
2.5.
$2.25, so therefore 225. Okay? That was number 22. And the next one is number 23. So these first 4 at least are in order for you. Okay? This next one, I have 2 to the 4th power divided by 2 to the negative 1 power. What would you do there?
Move 2 to the negative 1 to the top.
Move 2 to the negative 1 to the top. Why? What does that do for us?
Makes it positive.
Gives you a positive power. So this would really then become 2 to the 4th times 2 to the 1st. When you multiply, what do you do with the exponents? Add them, so that would be 2 to the 5th. Then you could probably get out a calculator and get your answer of 32. There's, again, kind of lots of review here on these exponent rules. Any questions on this first slide, Paul? Okay? Alright. Now, I am jumping ahead to problem 28 here at this point. Okay, I'm jumping ahead to problem 28. So we did 20, 21, 22, 23. Now I'm skipping a few and I'm jumping to problem 28. So here I have 27 divided by 27 to the 2/3. When I look at this one, without doing a calculator idea here, I would probably think of 27 as 27 to the 1st power. So I have 27 to the 1st divided by 27 to the 2/3. And when you divide, you subtract those exponents. So I'm going to be taking an exponent of 1 and dividing by an exponent of 2/3. So really I'm just going to do 1 minus 2/3. Okay, 1 minus 2/3 is 1/3. So I have 27 to the 1/3 power. Okay. Then, I still don't think you need to get out a calculator, you're welcome to, but 27 to the 1/3 power is really what type of root?
Cube root.
A cube root. Okay? You should be able to tell me what the cube root of 27 is.
3.
3. Yep. 3 times 3 times 3 gives you 27. Okay? So the cube root of 27 would be 3. Alright? Any questions on that one? Another way to do that, I think some of you will get this mentally here, 27 to the 2/3 power is 9. Because if you think about it, 27 to the 1/3 power is 3, so 27 to the 2/3 power would mean 2 of those 3s, 2 of those 1/3s. So 3 times a 3. Okay? Or it's 2 of the 3 things needed to multiply to 27. So just 2 of the 3 3s needed to multiply to 27. 3 times 3 is 9, so I have 27 over 9, which would also give you a 3. Okay, 64 to the 1/12 power. Okay, you get this on your calculator, you're going to get some decimal answer. I want you to leave it as an exact answer, or in other words, simplest radical form. Okay, so to do that, I'm going to write 64 as with a base. I'm going to break 64 down basically into its prime factors. So if I break 64 all the way down into its prime factors, it would be actually 6 2's. 2 times 2 times, there'd be 6 of them. So really what I have here is I have 2 to the 6th power raised to the 1/12 power. Now, when you take a power raised to another power, you multiply those powers together. 6 times 1/12 would be 6/12, or 1/2. So really all this becomes is 2 to the 1/2 power. So 64 to the 1/12 power is the same thing as 2 to the 1/2 power, or you could even write it as just a nice little square root of 2.
So either way, those answers work.
Both of these would be fine, both
Yeah.
of these last two, yeah. Because this is as simple as you can essentially write it with a fractional exponent. You're always welcome to change fractional exponents to radicals if you would like, okay? Unless directions would tell you differently. Okay? Well, that was number 30. Sorry, I forgot to tell you we skipped 29. Okay, so that was number 30 there. The next one I wrote down was number 32. Also tried to hit some even ones since I know the odd ones are in the back. Next one is 32. Now again, I know you could probably do this on a calculator, but I like to talk through the process a little bit and make you think about different bases. Okay? I believe I can get everything in this problem to have a base of 3. So here I have 3 to the 7th, so I'm going to leave that alone. 9 to the 4th, what could I replace 9 with so it has a base of 3? 3 squared. So what I'm going to do is I'm going to write 3 squared to the 4th. Because that's the same thing as 9 to the 4th, right? Okay? And then on the bottom, I'm going to go to the square root of, what could I replace 27 with so it has a base of 3?
3 cubed.
3 cubed, or 3 to the 3rd. So I'm going to say 3 to the 3rd to the 6th. Alright? So now I have 3 to the 7th times 3 to the, careful, power to a power. You multiply, yep, so 3 to the 8th. And then here I have the square root of 3 to the 18th. Yep. On the top, 3 to the 7th times 3 to the 8th would be
3 to the 15th.
3 to the 15th, because when you multiply, you add the powers. And what's the square root of 3 to the 18th? What times itself would give you 3 to the 18th? Shouldn't have to think too hard here. 3 to what? Nope. What times itself would equal 3 to the 18th? 3 to the 9th. 3 to the 9th times 3 to the 9th would equal 3 to the 18th. Right? Because when you multiply, you add powers. If you can't visualize that, another way to think of it, this square root is actually what power?
2.
Square root. Square root is not a 2 power. Square root is a,
Or 1/2.
it's a 1/2 power, right?
Oh.
So really this is like saying 3 to the 18th to the half power. So you'd have a power to a power. You'd have an 18 power raised to the half power, and when you raise a power to a power, you multiply. What's 18 times a half? 9. Okay? So that'd give me 3 to the 9th on the bottom. And lastly, 3 to the 15th divided by 3 to the 9th would be 3 to the 6th, because when you divide, you subtract. Okay? 3 to the 6th. And I don't know what that is. 27 times 27.
729.
729. Okay. I'm out of space. 729. Okay. I know you probably could have done that a little bit faster, a lot of different ways, but I thought talking through the process would cover a lot of different exponent rules for us there, and hopefully expose you to things that will make other problems easier. All right, then I got just a few more. 3 to be exact. Okay? This is problem number 38. This is problem number 38. 4y to the 4th raised to the 3/2 power. I see a lot of different ways to potentially do this one. What thoughts might you guys have if you see this? You want to take a guess? Just want to hear me go.
Go.
Okay? Looking at this one, I would go ahead and just raise everything in the parentheses to the 3/2 power. Okay? So that means I would take 4 to the 3/2 power, and I would take y to the 4th to the 3/2 power. And when I raise a power to a power, I multiply, right? 4 times 3 over 2 would equal 12 over 2, which is 6. So actually, I'm almost done already. I just need to figure out what 4 to the 3/2 power is. Well, here's my thought process without a calculator. What's 4 to the 1/2 power? 2. So 4 to the 3/2 power would be 3 of those 2's. So 2 times 2 times 2. 8. Okay? Yes, you have calculators that can do that for you. Alright? But I'm just trying to teach you how to not be afraid of fractional powers. They usually come out pretty nice. Okay? So again, my thought process was 4 to the 1/2 power is 2. So therefore 4 to the 3/2 means I'd have 3 of those 2's multiplied together. 2 times 2 times 2. So 8y to the 6 would be my thought process on that one. I could have changed things to radical form. I could have written it as the square root of all of this to the 3rd power. The problem would have taken me a little bit longer, but I could have still gotten to the same place. Okay? Alright. This next one is problem number 40. So we have a 2x that's being raised to the 4th power, and then all of that's going to be raised to the -2 power. If it were me, I would probably go ahead and I'd just see something raised to a power to another power. I would multiply those powers together and write my answer with a single set of parentheses as 2x to the what? -8. Then I have negative powers, so I move it to the bottom of the fraction, and I'd have 1 over 2x to the 8th. And then I would just raise both of those to the 8th power. 2 to the 8th power, well, let's see, 5 is 32, 6 is 64, 7 is 128, so 256.
Yes.
Okay? So 256 x to the 8th. So 1 over 256 x to the 8th would be the answer to that one.
Oh.
And the last one I'll do for you here is number 42. When I look at this one, I could do it 2 ways. I could raise the top part of the fraction to the 1/2 power, and then raise the bottom part of the fraction to the 1/2 power. I could do both the top and the bottom. That would be one way to do it. But when I glance at this fraction, I actually notice that I could simplify that fraction into not being a fraction anymore. Okay? B to the 2n power divided by b to the -2n power, they have the same base. So since they have the same base, what can I do with the exponents? Subtract them. What's 2n minus a -2n? 4n, right?
Yeah.
So really what I have is b to the 4n raised to the 1/2 power. Now I don't need to raise both the top and the bottom to that 1/2 power because I was able to simplify it. When I raise a power to a power, what do I do with exponents? I multiply, so 4n times 1/2 is 2n, so final answer, b to the 2n power. Okay? So, I did a bunch of exponent ones there for you. Tried to hit a lot of different examples, a lot of different rules. Do you guys have any questions over what you saw? Maybe something that's still a little bit confusing for you that maybe I could show through a different example, making one up or finding one in the text. Okay.
Wait, one question.
Yes.
So why isn't the 1/2 on the end, too?
On this here,
Yeah.
Oh, yeah.
why isn't the 1/2?
Uh-huh.
Yeah, why doesn't it apply to that end? Because we used it on the 4, but not the end.
Sure. Okay. When you raise a power to a power, you multiply, correct?
Mm-hmm.
Okay. So what am I going to be multiplying together?
4n 1/2.
4n and 1/2.
Mm-hmm.
Okay, so if I take 4 times n times 1/2, for example, if I tell you to take 3 times 4 times 5, you don't take 3 times 5 and 4 times 5, do you?
No.
No.
you just take 3 times 4, get that answer, and take it times 5.
Yeah.
Okay? So I'm not taking the 5 times the 4 and the 5 times the 3. I'm not taking the half times the 4 and the half times the n. I'm just multiplying the 4 times the n times the half.
Okay.
What order you do those doesn't really matter. Okay? 4 times n is 4n. Times 1/2 would be 2n.
Gotcha.
Or do it a different way. 4 times a half is 2. Times n would make 2n. N times a half would be how much? 1/2 n times 4. 2n. Either way, you're going to get 2n. Okay, so just think of this not, it's not a distributive property. You know, it's not 4 plus n where you got to take the 4 and the n and multiply that sum to the half power. It's just, it's already a product. So that's already the product of two things times a third number. So it's like I'm multiplying 3 numbers together. I'm multiplying the 4 times whatever the number n is times the number 1/2. And when you multiply 3 numbers together, it doesn't matter which order you multiply them, but you definitely do not take, you know, 3 times the 4 and the 3 times the 5. You just take that times that, get that answer, times that. Does that clear that up?
Yeah.
Good question though. Okay? Alright, any others? Alright, so try to finish these up then during the remainder of our time.